Here's one who, when I hit 923 hertz with what I call the normal geometry of the plasma bulb, he suddenly, dramatically exploded, unexplainably, while some of his friends are happy as little clams. He exploded. He stopped swimming, he suddenly turned into some dramatic different shape, and he exploded. Incredible. This is a very strong blepharisma who has survived on the slide when everybody else has died. There were maybe 5 or 6 of them on there. Some died dramatic explosive deaths. He was so tough he was pushing debris around on the slide. I've never seen that before. He's a really tough organism. The scale is correct. We have the 10x objective. He's sort of stuck now. I think he's trying to squeeze between the cover slip and a piece of debris. He's very stubborn. So he's just stuck. I think the plasma wave is doing it. 926 hertz. He's gone through 3 programs that had effects on other organisms. Maybe we're seeing something in here. I don't know, he still has cilia action. He is tough. Tough little guy. Let's keep our eye on him just in case. That's an air bubble. He's hugging. Oh, look what happened. Quite a bit of cilia stopped moving when he touched that air bubble. But he does still have directed motion. He's still going. Nope, he's still going. He cannot be stopped. He is tough little guy. Wait, watch him carefully now. Look what happened just now. He suddenly and dramatically disintegrated. 926 hertz at the end of the 3rd minute of 926 hertz. That was dramatic. He showed no sign of giving in. Now let's look very closely at the next objective. What happened to this guy? This is the 20x objective. And it looks something like the other guys we've seen on the slide, who just suddenly, almost inexplainably, blew up. Incredible. He suddenly turned into like 4 separate balls and exploded. Almost without warning. See that? His body's been like turned into 4 separate spheres. And here you can see the internal contents of the original organism leaking out. Oh, and here, look, it burst. It just burst open. The internal contents are leaking out through a cell wall. That was in the final seconds. And who's this coming into the picture? There's another guy coming by here. I don't know who that is or what he's doing. Let's get a little better look here. Let's go even closer. We're going to take a chance with the 40x objective and take a look at this destruction. Look at, you can see the contents emptying out here. He's just completely emptying out here through a hole in the cell wall. fantastic dramatic display. If I put a filter on there, maybe you see it better. Maybe not. Here's a red filter. We're just going to experiment with filters and see if we can display what's happening a little bit better. That looks pretty good. I think that's a yellow filter. That's really looks good. Incredible dissolution of the organism. I would say very dramatic. Internal material continues to stream out onto the slide. It was phenomenal because he was so strong, he showed no sign of giving into the frequency until the very end. And it looked like 926 hertz was for him the magic number. So we've been getting hits between 923 and 926. You might want to start running 923 to 926, specifically focusing on those frequencies. Tremendously dramatic. Let's go back and do a wide shot again. You get some appreciation for what's happened to him. There's the 20x objective. He's really literally a shadow of his former self. And here is, I believe this is the 10x objective, yes. And you can see another view. What's interesting in this view, if I could focus the microscope, all this material used to be inside of him, and now it's just all over the slide. And if we go to, and now just to show you that the frequency was very selective, I'm going to go to an organism who is very nearby in the slide. Let's see, maybe we can find it if we go to 4x and we focus. Okay, we're focusing on the remains. There's no way you would recognize that as the remains of blepharisma. But if I move a little bit to the right here, coming into your picture with the 4x objective, this is a Vorticella, and he's alive. And I'm going to show you that he's alive because you'll see his mouth and cilia movements here. So watch carefully now. So here you see, this is under the 40x objective. So 10 micrometers across here is correct. You see action. These are the cilia in the mouth of the nearby Vorticella. It was very close to this blepharisma, which exploded, very dramatically exploded. So here we have proof that we have found a specific frequency that affects the blepharisma, but does not affect the Vorticella in the same way. There you can see now. I think if you watch carefully, you'll see cilia action. So he's alive, and he just suffered no apparent ill effects from the program, which destroyed all the blepharisma on the slide. Okay, it's 10:16 p.m. on June 28th, and we have a new slide, and I wanted to show you. This slide is very, very rich in organisms. They are all over the place. There are tons of blepharisma, big and small, as you can see. I'm going to scan through the slide real fast and watch how many you're going to see. We start along the far right corner. My God, they're just loaded This slide is loaded with blepharisma. They're everywhere. First thing we do is we scan the slide. Now that's their food, those little tiny guys. And we slide by here and we make a mental note of the geography of the slide and the geographical location of some of the organisms. Air bubbles are very helpful in orienting yourself. In fact, this is one of the healthiest slides of blepharisma I have ever seen. So we're going to start our program now on the plasma device, the Rife plasma device, and we're going to run a special set of frequencies I programmed into the F125. This is just incredible. There's so many on here. And look at this dramatic cluster here of guys. They're just all over the place. So this is a really fantastic slide to test with our program Blepharisma 11F, which had some dramatic success earlier tonight. And I already found a victim in the first minute and a half. See if we can focus. He's already distorted here. Right here. And he doesn't look right inside either. He has cilia movement, but he's already been affected. 100 watts, 1.3 SWR, it's a little high. 923 hertz. And we'll keep scanning and see if we see any other guys. They look funny. This is happening in real time. It's a slide that has a lot of blepharisma on it. So I can really quickly go through here and find them. They're just all over the place. Look under the wax here. Here's one that is in a kind of a spasm. You sometimes see that. I'm continuing to search the slide, but you do see that behavior when you're getting close to a frequency and they're not very happy about it. It's not his normal shape. He's sort of bent over. Here's a different one who has stopped moving. We could watch him closely and see what happens. There's so many on the slide. I want to sort of keep moving around the slide and see how many at once we get. But so you can see this might be the first sign of distension here. It's not clear yet, but he's not moving. No directed movement is usually a sign you have hit a sensitive frequency. We're at, the wattage dropped a little bit. Bring the power back up. 90 watts, 1.3. You do have to fuss with the tuner. Sensitive. 100 watts, 1.25. I'll come back to him. Oh, no, he is there. He's showing signs of distension there. See that? That's common. Up, and we're getting like a blister or something. Let's get in a little closer. See if we can't make out what's happening with this guy. Let's watch carefully. This is real time. Oh, and he looks like he's breaking through the cell wall. This is live in real time. This program's been running about 7 minutes, and you're seeing live what's happening. It looks like he's going to break through the cell wall here. It's pretty dramatic. We're going to stick with this guy. I have a feeling many of them are being affected right now, but let's stick with this one and see what happens. I'm guessing that's a distension of the cell wall, and it's going to burst. So we'll stick with this one. And you can see moving around him. This is the 10x objective. So the scale is correct. Here, watch carefully here. Moving around him are these, I believe these are actually intended to be his food. He has no directed motion, and he's bulging more and more here. So we're watching this happen in real time. Let's watch carefully. I have to watch the MFJ tuner, which is very sensitive to my approach. 926 hertz. We're at the last frequency. We have about 2.5 minutes left in this sequence. And the protuberance is larger. But will he actually be destroyed? We don't know. It looks promising. And it slightly grows and grows, but there's only about 1 minute left in this sequence, so we don't know if it's going to work or not. Let's watch real time. Watch carefully. Changes are happening. 1 minute and 39 seconds left, and the frequency is 926 hertz. I believe there's a rounder, bigger extension sticking out here. We are not seeing the dissolution of the internal organs in this case. So this is an interesting example. There are many blepharisma on the slide, and we may, by focusing on this one, we may be missing quite a few others who are having even more dramatic effects. But we're going to keep an eye on this. He's quite round, so he doesn't have his regular shape. The cilia is very active. You can see the cilia along the left side here, quite active. We must be down to about our last 30 seconds of the program. Yep. And last time we saw a dramatic effect here in the last few seconds. So we'll hang in there and see what happens. See if anything happens. Seconds remaining. We're just about done with this program. And this guy was pretty tough. So he survived. Plasma light is now off. Let's scan the slide and see what happened. So now we show you some different organisms on the slide. Here's a bleph who got very round, and is a little cilia motion, but he is distended. Nearby maybe is another one, I'm not sure, but that's a typical round one, maybe a very, very small. let's look at some others on the same slide. 4x objective, so 100 micrometers. Now I'm going to show you in real time what I'm seeing as I scan the slide, because it's kind of unbelievable. I'm just seeing one organism after another who's not moving. They're not moving at all. They haven't necessarily exploded, but you saw the short time ago, this is me moving the microscope stage, the organisms are not moving, and there are many of them, and just a short time ago they were moving all over the place. Now, for example, that one does still have some cilia action here, but he has no directed motion. So I don't know if they're wounded. There's one who's starting to move down a little bit. See now, he's a little different shape. To show you that some survived, there's one very slowly moving, and see, he retained his shape. But if we come back up, the bigger organisms seem to have been pretty dramatically affected. There's a little one, see, he got away. But look at these big guys. No movement whatsoever. I do see cilia movement, but I don't see anything else. Let's keep scanning the slide. Okay, now here we see some who survived on this side. Let's see which way we're going here. Quite a few. So we'll give you an idea. See, now these guys survived. And they look pretty healthy. Not too bad, and there's a lot of them. So the question is, where is that on the slide? That seems to be the part of the slide that is closest to the plasma light. Isn't that strange? And when I go to the other side of the slide, this is the side of the slide which is furthest from the plasma light, and I can find many organisms, none of whom are moving. I prepared this slide by hand, not with the bear jig. See, he has cilia action, but he's not moving. This could be what Rife was talking about. He meant revitalizing a lot of them all at once. There are some more. Here's another one. No motion detected. Here's some smaller ones. There's a small one who's not moving, and you can see a small protuberance here. There's another small one, not moving. And the funny thing is, it's the side away from the MFJ. Sometimes I thought maybe the MFJ, the fan that keeps the MFJ cool, dehydrates the slide, but these guys are on the other side. They're farther away. Here's one who's not moving, but his cilia is moving. So as I'm sitting at the microscope slide, the guys on the right side of the slide are not moving, and the ones on the left are. Which is very interesting. Okay, here are some guys on this side moving. They seem to have escaped the effects. We have a few who survived here. But, oh, some of these big guys are still alive down here, okay. There's one who is not moving, and actually has a blister. Looks like he suffered a collapse there. Let's see, there's another one here. not moving, and look at that internal giant vacuole. It's not quite the normal. Here's another one. Not moving. Two huge vacuoles here. We're going along the bottom of the slide. As we get over here, we start to see some smaller organisms are alive and moving. Here you can see quite a few. Here's one with had a sort of an odd shape. And he was partially affected. Now we're on the other side of the slide, right under the cover slip, which is closest to the plasma light, oddly. And we can see we have quite a few. Look at that. Quite a few of these guys are alive over here and happily swimming. So one theory would make us wonder, why are so many alive and happy on this side and on the other side not? There's some with huge vacuoles who are still swimming. I think they were affected, but not enough to kill them. Now, as I move to the others, just a little bit of distance down in the slide, not very far at all. Right, there's the one side. I just head a little bit farther, and all of a sudden I encounter all these guys who are not swimming. There's one. And above him are 4 or 5 more. There's one next to him. Notice he's distended here. Here are 2 more right next to each other. Notice the extra spheroids and the distended shapes. You do see this has almost no cilia motion. He has a lot of cilia motion, but he has no directed action. Continuing nearby, there's another one. See the blister? He probably popped his, right below him is another one. Look at that. Complete, utter, total destruction. He looks like an amoeba. There's another one right below him, right there, completely destroyed. Now I'm continuing in this direction on the slide. There's another one completely destroyed, and right below him is another one completely destroyed. This is the most dramatic experiment I've seen in this example. I maybe can hold on, the computer needs a little action in order to stay awake. We'll try to focus a little better. This one has a clear blister here. Let's continue. There's a little one down at the bottom, not moving. And we are searching and finding more. Here's another little one. He's not moving. There's a little one that got round and is not moving. There's some more on this side of the slide. Let's see if I can find them. There's some more. Oh, that's a Vorticella on top. The bottom one is Blepharisma, not moving. But I see a little guy swimming in there, so there's still liquid. And there's some more going down that side of the slide. This one has cilia movement. He has a little bit of action, not too much. It's kind of slow. There's a couple of slow swimmers down there at the bottom. Here we go. There's a few guys down here who survived. but quite a few who didn't. There's another one. Look at that total destruction. This was so successful that the next step would almost be to take a counter. Here's a whole group of them now. I'll show you a group. And different sizes too, which is kind of interesting. Here's some guys. Look at these two guys. They're not moving. See that? And then I'll bring this. I'm moving that microscope slide. That one, not moving. And then there's a little one above that to the right. This one, not moving. And they were all swimming happily. And then this one turned into a complete amoeba. Complete destruction. Fascinating. One almost wonders if that tells something about the angle. Here's another amoeba type destruction. Here's some smaller ones. They have no motion whatsoever, a little distended. Let's see, what's this one? There's a little, I think that's a little one. Not too sure on that one. Here's another one that completely fell apart. And boy, they actually got worse and worse as time went on. But this is the most dramatic effect I've seen. Here's another one, totally shattered. Look at that, bursting at the seams there, a big blister. The blisters are a sign that the cell membrane broke. Here's another one who's not moving. We're getting to the point where you can almost go to the next step in the experiment. These guys are not moving. The next step perhaps would be that we are counting how many are disabled. Rife talked about devitalizing. Now here's a good example where you'll see one who's alive and moving and then one who's not. We're getting over to the other side of the cover slip, which is very near the plasma light, and all these guys are pretty happy. So now this is good proof that there's adequate water in the slide. They are not dehydrating, they're not being crushed, because not very far away are these guys who just stopped moving, and some of whom turned into total blobs and have blisters. See, he has ciliary action, but he has a blister, and he has no motion. And very close to him, nearby, I'm trying to give you a sense of how close, are you know, a dozen or 15 guys swimming around. So we're going to try an experiment now where we take this slide with all these Blepharisma. There's still quite a few living. We'll see. And there's one. Now there's one who was affected. Let's see if you can see that. He was badly affected, and yet most of his companions in that part of the slide were not. That's fascinating. And then down here we see more guys still swimming. Quite a few. The skinny ones seem to fare better. There's a few more swimmers. So what we're going to do is swap the slide, switch the slide around so that the geometry is changed. And these guys who lived, who were near the plasma light, we'll take out the slide and we'll flip it around. And now these guys who lived will be farther from the plasma light. And we'll see what happens. Let's see if we can find them. So now they're farther away from the plasma light. Plasma light's to my left. And let's do a last check here. We have quite a few guys you can see swimming by here. Pretty healthy. So we'll run the same program and see what happens on the slide. This would explain, or would seem to indicate, this would seem to indicate the fact that half the slide was killed and half the slide was not. There's some kind of directionality going on here. Very interesting. Let's run it again. Okay, we're going to show you in real time. We have rotated the slide 180 degrees so that the organisms who were closest to the plasma light before and survived so beautifully while the other half did not, now those organisms are on the further distance from they're the furthest side of the slide from the plasma light. Whoa. And already, just scanning, we had a lot of action going on here, but here's some guys swimming. That's an air bubble. It doesn't really affect anything. And we're on the edge of the slide there. So now, this is the edge of the slide furthest from the plasma light. The plasma light is set up in what I call my normal geometry. Now, I have a feeling that 90 watts is optimal, so I'm going to shoot for 90 watts and an SWR of about 1.2. Here we go. The MFJ requires a little tuning, and this is great. You're seeing this live. So we have 90 watts, 1.2 SWR, 922 hertz. Now, 922 doesn't seem to really bother anybody, so I should probably rewrite these programs starting at 923. So we're going to watch these guys in real time. This is about a 15-minute program. And we're scanning, and you can see what's happening with some of the work. Look at these guys getting some pretty oddball shapes early on. This one's looking very strange. There's one huge vacuole in the middle. 90 watts, SWR 1.2, and we are at 923 hertz. I think that's the frequency we should be starting at in the future. Using a phenotron bulb. Let's pan around and see what we see. These are the guys now furthest away from the plasma bulb. They're to my right on the microscope stage. Plasma bulb is to my left. Let's see what else we see here. Here's some. You're watching this in real time. Here you can see changes here like we've seen before. So there appears to be, if this is successful, there appears to be a geometry. Now look at this. Here we have a dramatic destruction. Let's see if any more guys are going to do anything. Here we have all people who have stopped swimming. The lifeguard has called out and said, "Stop your swimming." There's a few tough guys struggling. Look at that huge hole in the middle of him. He's tough. We'll try to give you a good focus here. Stand by. There we go. That's pretty sharp. This is real time. The second run, after having rotated the slide, now you see this tough guy. He's getting really round. 90 watts. SWR 1.2, frequency is 923 hertz. We're running from 922 hertz and in one hertz steps. So we're going to keep scanning the slide and see who's moving. Not too many guys are moving. Here he has a protuberance here. Keep your eye on the tuner, 100 watts. The tuner climbs as the frequency changes. Also, as your body approaches the plasma light and the MFJ, you will find the tuning changes a little bit. I'm going to try to retune it to 90 watts. I don't know if there's a difference, but we've had a lot of success at 90 watts, so let's keep going. There's one who's completely, look at that, completely destroyed. This is in real time. His shape is completely released from his original shape. This is a dramatic telling. Now he's a different shape, so he's not being affected right away. This is real time. We're running 5 frequencies for 3 minutes each. 922 hertz to 926 hertz. That guy's a goner. He's not coming back. That was dramatic.